Hey everyone, good evening. This is Anupinder Singh and welcome to Superwits Academy. And today we are live to talk about standard template library, and we are going to look upon a couple of concepts from the template library, how we can utilize it, what are the different components within it, uh, how they can be used to write high quality programs and so on. So all these stuffs we are going to talk about. So let me just move to the screen so that we can quickly hop on to our things. So I have a slide available for me, and this particular slide is basically going to help us to be on the track. Side by side, I'll show you some of the basic resources. Before I actually go ahead, just want to check my audio and video. Are they are okay or not? Just need to check them. Just allow me a minute to do so, so that we can get continued with the things without any hassle. So just to check that we are live. Yeah, almost. Yes, we are. And I can see uh, a minute. Okay, to do so. Oh, great. So we are live. I think my voice is also okay. So let's get started with the particular thing. So I'll be talking about the concepts along with the actual resource, right? Because most of the time, whenever the webinar happens, the uh, PowerPoint is used or some code has been used, but no resources are being discussed where the people can go back and check on for their practice purpose, right? So I'll be using c++.com for this particular part. So side by side, I'll be referring you to the API that the STL is providing us, uh, and then we are going to look at that what is the specific code they have given us and so on. So this webinar is going to be of 60 minutes long, and during those 60 minutes, because 60 minutes is too short to talk about all the concepts of C++ STL. So we'll be touching upon the basics, and then I'll give you the launchpad to go further and practice on the particular things, right? So let's get started. So here we start, and yeah. So just before we get started, I just want to repeat. My name is Anupinder Singh, and uh, I am basically a software engineer by heart, and was turned into university professor, and now I have been doing technical training since last 1.5 year on C++ as well as machine learning basis, right? So this is what generally I do. So let's get started with the very first thing, just to give you an idea that what this particular STL is all about, and who has actually brought this thing into the picture, and how and what are the basic components around it. So Alex and Mang, these were the two programmers at HP Labs who have actually utilized the concept of generic classes and generic function templates, and they actually built up a very well tested and well written code, which has been later on named as the standard template library. Again, it was just brought out from the need what these guys were having during their time, and it was uh, during the 1990s, right? So that's the first time somebody has wrote this particular piece of code for us. And in 1994, the code was so well written and so well tested that this code was included into the C++ standard specifications under name of STL, Standard Template Library, and they have been adopted under ANSI ISO Standard C++. So that is what is the basic history about that origin of this particular STL all about. And when you talk about the components that it has, there are three basic components which were being introduced under this particular piece of code is. One is the is basically the container, second is the algorithm, and third is the iterator, which is basically the part of the containers set. Right now, what exactly is the container? So whenever you talk about STL, these are the three things which generally comes to your mind. So what exactly is the container? So containers is nothing but it's basically a generic class templates which are going to store some collection of data, right? And this collection of data is basically similar type of data that is there, right? So uh, the most common container which people use is the vector array, list, and so on, right? So there are somewhere around uh, uh, 12 containers which are being published out in the STL. So they are basically the generic templates. When I say generic, the type of the data is not defined while writing the code, right? It has been generically defined in terms of the data structure, and the type is decided on the runtime basis, right? So that is what you call as a container, right? Then next thing which comes in the picture is basically the algorithm. The algorithm is another uh, piece of code that has been contributed by both of these programmers. And what exactly that contains is that contains the generic function templates for operating on the container. So that means the functions are being some generic functions are being generated where the particular piece of code has been written for them. So that code is actually going to help them in that code is basically a predefined code on binary search, on sorting, on relevant things, right, and so on. So all these particular piece of codes are basically going to work on the containers, right? And the iterators are basically generalized smart pointers that facilitates the use of containers and provide an interface that is needed for the STL algos to operate on the containers, right? So this is basically a kind of interface, or you can say a kind of medium through which the containers are going to be accessed through the piece of particular piece of algorithm. So overall, when we look at the big picture, this is how you can actually make them out. The C++ STL is basically going to be comprising of the algorithms and the containers, and iterators are the ones which are going to connect them together in this particular context, right? So the iterators are the one which are going to be used by the algorithms. The iterators are the one which are going to be uh, 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 sharing the pointer details corresponding to the data structures that are being represented by the containers itself, right? So this is what you have in terms of the overall big picture, right? So when you narrow down on the containers, right? So containers are basically being categorized into three set of data structures. One is the sequence, one is the associative, and one is the derived. So when you talk about the sequence is going to be vector, DQ, and list. Uh, Apart from that, the associative is going to be set, multi-set, map, and multi-map. Derived is going to be stack, queue, and priority queue. So, what is the basic what is the basic utility of these particular piece of containers, right? So when you talk about the containers itself, so when we look at the vectors allow you to have storage of the particular type of data which is similar in nature, right? And this vector is basically an extended version of arrays, right? And it allows you to have a dynamic size allocation to to the particular data structure. Okay, so this is what is going to be in terms of the vector case, right? It allows you to have a random access corresponding to your particular data elements that are being stored into the data structure. So this vector is going to get you that particular piece of operation that can be performed related to the different kind of operations which are being added along with that particular data structure, right? So vector is basically a class, right? So vector is basically a class which contains the data and which contains the operations that are associated with it, right? So to understand it more, right, in a better way, we should be looking into the resources which are being given on the c++.com, so that you can also refer to them at the later point of time. But before that, before I move on to that particular part, I would like to write this particular thing, that is API, application programming interface, right? So this is the container classes or the algorithms or the namespace under which these particular piece of code is defined. They all are basically nothing more than API, right, which can be utilized by just referring to that particular namespace, by including that particular header file, and so on, right? So let me just without wasting time, bring you to the actual source that you should be using. So c++.com. So this is what is the website that you should be using for this particular form or this particular webinar, so that you should be able to work around with the practice part. So where I want you to go and look into is the references section. So you go to the c++.com, you go to the references, right? Once you go to the references, you will find that there are options which are being provided on the left hand side. There is a menu which has been provided, and within the menu you will find that there is a containers that has been provided into this particular set, right? So the containers is basically this is basically a documentation which has been provided corresponding to the set of containers which have been available into this particular uh, piece of uh, piece of code, right? You can say the standard template library as well. So containers are basically the combination of different set of classes that are being defined, and you can see what are the different containers which are being available. So the broadly what we discussed into this particular piece of code is the sequence, associative, and derived. But when we actually go and look into the library, you may see some more piece of classes. So here the sequence containers are basically arrays, vectors, dequeue, forward list, and so on. Similarly, container adapters are going to be stack, queue, and priority queues. Associative containers, set, multi-set, map, and multi-map, and so on. So they all are being extended into different versions as well, right? So once you try to work on the code, because being a programmer of C++ or any programming language, you need to know that, okay, what are the different classes which are available in the API, and what are your standard library, and then how you can actually include them and work it around, right? So when you look at with that particular perspective, so let's look at the vector class first. That how this particular documentation can help you to work it around if you are just completely new to the standard template library part, right? So once you get into this particular definition, right, the very first thing that you look at is the std, and then you have been given a scope resolution operator, and then the vector is being provided, right? So this clearly states that the vector has been defined under the namespace that is standard, right? So all the standard template library, if you want to use, you're supposed to have that namespace included into your particular piece of code, right? So if we talk about this particular set, so if I say include IO stream, this is my basic first line of code, and then using name space std. So this is what you actually bring into your part. So int main is going to be provided, and then this is going to be returning the piece of code. Return a piece of code over here, right? So here, once you look at this is a very basic code that we have right now. So if I want to use vector, right, so let me bring you back to the vector again. So vector are basically sequence container representing array that can change in size, right? So they are dynamic in nature. So what are the basic piece of definitions they can have, or the declarations they can have? So because this is a class. Vector is basically a class in C++, right? So if it is a class, it will contain a constructor, and that constructor will actually tell you that what is the way it can be declared. So you can see there are four ways we can have the particular vector defined. One is the empty container constructor, which is a default constructor. So here the container will have no elements into it. Second is the fill constructor, where you actually copy the values. The range constructor, you pass on the values into that by using the iterator of first and last. And the copy constructor, that means uh, you can have the other vector copied into this new vector that you are trying to create into the particular set, right? So once you scroll down, you actually get a piece of code over here which has been provided, right? So as we mentioned, that vector is basically a class which has been defined, right? So you have to have that include done for that particular container to be used in this particular program. So how you define the vector? So as we said, the vector is basically a generic class is generic class template based class, right? So vector, as soon as you try to define the vector, you actually get these angular brackets available, right, where you define that what is the type of that particular vector you're going to be. So it can be integer, it can be float, right? So anything which which you want to define, that can be defined into this. So list, I would say list vector, we are going to define. So at this particular point of time, this vector has been declared by using a default constructor, and this vector will be empty, right? So how do I know this vector is empty, right? So the vector is going to be cout. Just go and check that what is the basic size of this particular vector. So I would say size of the vector is size of the vector is, and what is the size? We simply write the size is going to be, okay, so let me just put my system to the power saver mode. So here you can see because the vector name is the list vector dot, there's a size function which can be used which can be used to check that what is the basic size of this particular vector right now, right? So this is the very first constructor that we have just called into this particular part. Let me just clear the screen and let me just run it again for you guys. So here you can see the size of the vector is right now 0, right? So if I want to have some kind of elements that have been added to this particular list, so there are certain functions which have been or certain operations which have been defined along with this particular vector data structure, right? So if you want to check that particular part, you can actually go to the basic definition for this particular vector class. So let me take you back to the core page of the documentation. So here, once you go and scroll down, you can actually see that what are the different functions which have been defined into this particular class. So one is the iterator, which is basically nothing more than giving out a pointer to that particular vector instance. Then there is a capacity. Capacity is going to be that various functions which are being provided. So one is the size, which we have just used. One is the resize if I want to change the size. One is the capacity. Now there is a difference between the size and capacity over here. That means it returns the size, that the existing size of that particular vector, whereas the capacity is going to get me the total allocated storage to that particular capacity, right? So if I go back and if I try to make a copy of this particular code, paste it over here, and instead of size, if I put up a size capacity of the vector is, and then if I put up a capacity into this particular part, right? So in this particular case, what is going to happen is you will be able to appreciate that both of the capacity and size is going to be 0, because there is no element that has been provided into this. Now, because I have used a default constructor here for setting up the setting up the vector element, right, or vector list. So there should be some method that should allow me to push the elements into this particular vector after creating that particular vector instance, right? One way is either I put up the particular set of values. So let me just show you what are the ways. So one way is that I should put up a simple empty vector. Another way is that I should put up a size, and followed by that what should be the number that should be given at each particular value. One is creating from the iterator, and last is creating from the another list, right? So if we go back and try to create another list, let's say, let me just copy this and paste. The vector is going to be vector. This list is going to be list pre-populated, right? And once we try to pre-populate, the pre-populate is going to get me a size in the first place, right? You can see the size is the first is given in the first place, and then what could be the possible value that we have to put up at each individual size, right? So as soon as you push this particular element, so this is not by the default constructor but a overloaded constructor, and this vector will have four elements with each index containing value 10, right? So how do I know the value 10 is going to be? That we can do by using the for loop and so on, right? So just to check that what is the size and so on. So size, let me just copy and paste. So here the size of the pre-populated vector and the capacity of the pre-populated vector is going to be here. So list, instead of vector we are going to have pre-populated, so I make a copy of this and then we are going to paste it over here as well, right? So let me just push them toward this. So here, as soon as we try to populate the thing, so size of the first pair of the vector which was declared through the empty uh, elements or default constructor which has no element allocated to it, it is 0, whereas whatever the pre-populated values we have given, it contains 4, right? So what if I want to see what is the value that has been given? So again, the for loop can be used, and there are two ways it can be used: int I, or maybe count equals to 0, count less than, right? Now we know the size, okay? So list pre-populated values dot size is going to give me the size of that particular vector array list, and then count is going to be plus plus in this particular case, right? So this is one way we can have. So see out, and then here element at index, and the index will be populated through count variable, and then we are going to have that beautiful way to put up the things. So here we can have list pre-populated. Now because vector is basically an extended version of array, so I can use the square brackets to represent that what is the array index that we are going to have for this. So here I can put the count as an array index. So again, vector is extended from the basic representation of the array, so it utilizes the same syntax and scenarios for the for its accessibility as well, right? Along with the additional methods, right? So as soon as I have all these elements associated here, let me just put up an handle manipulator. So here, as soon as you go and try to print it, so you will find that every individual element at any of the index is going to have its value associated with them as 10, because we have pre-populated that value to the system. So what if I do not want to have these particular piece of values associated? You can see as soon as I remove that second argument into this particular constructor, uh, a representation for that particular vector class declaration, vector element or object declaration or container declaration, the values are being removed, and they are being by default set to 0. So this is what is there in terms of defining your own particular set of vector into this particular part, right? So what if there is no way we can have the pre-populated elements or pre-filled elements into this particular piece of just before I move on to that particular part, I just want to show you one more way how the for loop can be utilized. So here, what I can have is, because I know the type is of integer, so I can use for int uh, let's say count, and that count is going to be coming from the list, and a list pre-populated. So every time the for is going to be working out the element, uh, this is a way we can say that the iterator is going to work around, and this list is going to be working out in that particular part, right? So instead of the count is going to be the element at the index count. So this is what is going to be working out for us right now, right? So you want to print the value of each list, uh, each element that is there in the list one by one. This is how it can be, populated. So as soon as you work out does not have a type, right? So the count list pre-populated. Okay, so if I have the element. Okay, so there is, yeah. So I think I missed this curly braces over here. So as soon as you work out on that individual element list, right? So this list is going to be iterated at each individual element, and it is going to get printed along with that particular piece of code. Just give me a minute. Yeah, so this is how this particular value is going to be printed. So instead of index, now the count is containing the actual element that has been stored at that particular individual list location, right? Each individual index location. Okay, so this is how you can actually utilize that particular piece of for loop as well, right? So this is where it brings a convenience of writing that particular piece of code, right? Now, the next thing is that what if I have declared a particular empty container, vector container, and I want to add information or elements to this particular individual object of that particular container, right? So let me bring you back to the particular piece of no, particular list of member functions. So we know the iterators are going to give you the list. We know the capacity is going to get you that, okay, what is the current status of that particular element. Then element access, that how we can actually access the element at a particular individual location. So at is going to replace the square bracket thing. And similarly, the modifiers are actually going to bring you the particular set of elements that can be aligned to the or assigned to a particular vector, right? So here you can see the push underscore back is a function that is going to be working out with the adding the element to the end of the list. So right now we do not have any end of the list. We have no element over here, right? So if I simply push the elements, right? So list vector, right? So list vector dot push back, right? So this is what is going to be. So push back, let's say 9 is the element I want to push to that particular list of the vector. And then as soon as I print this, I want to see what is the size and capacity, right? Uh, See out and new line, some streaks, and then we are saying after the element is pushed using push back, right? So as soon as I try to print this, right, we'll be able to appreciate that the size of the vector at the first place is 0. As soon as we are pushing the element, the size of the vector has become 1, and the capacity of vector has been 1. So the difference between size and capacity is size gives you the number of elements that are being stored into the particular vector. Going to give you the size of that particular vector in terms of memory, right? So this is memory allocation, right? So memory locations that we have is going to be represented by the capacity, right? So this is what you are going to see. Now with the vectors there is a very beautiful thing, that because right now we started with the 0 memory allocation, then we pushed an element to this particular list, and as soon as we push, the dynamic memory has been allocated, and the size has been reduced, has been increased increased to that to the particular list, right? With the one element. What if I want to have another element added, that is 19, right? So as soon as I push that particular element, you will find the size and the capacity is being again increased. And just analyze that how the size and the capacity is going to be working out, right? So here the one element was added, then the another element was added, the size has been increased to 2 and the capacity has been increased, is also increased to 2, right? What if I add another element to this particular part, right? So I'm adding another element over here, 19, and instead of 19, 29 is going to be added. Now if we run this particular program, you will find that the as soon as in one element is added, the size is 1 and the capacity is 1, whereas when second is added, again the size has been added with one value, that brings us to the 2 and the capacity is going to be 2. Whereas when we add another element, the size of the vector is going to be 3, whereas the capacity of the vector is going to be increased by 1x within the particular existing capacity, right? So whatever the previous 2x basically. So whatever the previous capacity you are going to have, the next capacity you are going to get is the double of the previous one, right? So when you are doing the dynamic allocation, right? So as soon as I push one more element to it, right, you will find the capacity of the vector will be increased to 8, right? Now this is going to be 39, and you can see the capacity is now increased to, okay, so 39, 19, 9, 19, and the capacity, okay, 4 was being done, sorry, I just created a confusion. As soon as I push one more element after the 4, because the previous capacity, the last capacity was 4, now it is going to be changed to the 8, right? So this is where when the capacity is being reached, right, the capacity is going to get double for the next element pushed, which is going to increase the size of that particular vector, right? So this is how the background function or method is going to work around, which has been included within that particular single container, right? So the point of talking about all these or giving you the demo of all this particular thing is that vector is not only going to get you the data structure, right? So it is not going to give you only the data structure, it is also going to give you the methods methods or functions that can perform quickly on that particular data which is being going to be stored through that particular structure, right? And vector is basically a class, and we know when a class is going to be having the collection of data and the operations which are going to be operated on that particular data, they are tightly bound. And because it is tightly bound, so this becomes an abstract data type in that particular concern, right? So the standard template library is basically nothing more than nothing more than a pair of specialized special function classes or special functionality classes which have the definition of their data structures or the member variables within them, and along with that, that what operations are supposed to be performed or can be performed on those particular pair of data structures, or that pair of member elements defined inside of that particular that particular generic class are going to be included within them, right? So this is where the container is going to be working around for you, right? And that is what this particular vector is giving, documentation is giving you, right? So vector documentation tells you on this particular dot com is that what are the different member functions we have, what are their categories of those particular member functions, what is the capacity, what is the element access that you can do, right? So just like if we talk about this particular at operator or data at function or data function is going to give you the possibility of working around with indexes and the data as well, right? So if we go and look into the code again, right? So if I want to print all the information again, right? So let me remove this for, and instead of the count is going to be working on the list vector now. List vector, right? So this is the list vector which we have just populated with the 4 element, and if we want to print them, so element, and so on, right? So if I just run this particular program for you, you can see the elements are being printed into this particular context, and you will be able to see that what are the different values that are being pushed into this particular element. So right now, last value I just update, it is going to be 49 now. So you can see 5 elements have been added to this particular list, right? Along with that, if I show you some more functions, so let me just see out. So I'm going to talk about iterators just soon, after this particular front and back function. So here, the first value in the list can be printed by using the list vector dot front. This is the function that is going to be there, right? And similarly, the last value in the list can be done by the back, right? So this is going to be front and back of that particular list, just to have n and new line over here, right? So if I have this particular element to be printed, so you can see the first element is 9 and the next element is 49, right? What if I wanted to have some index level? So value, let me just print one value at location at, I would say, index location 2, right? Or 2 of the list is going to be vector dot at, and as soon as you have this, you can see there are two constructors which have been given. So both are giving us the basic, it is going to ask us that which index you wanted to print. So 2. So when you talk about 2, the 2 is basically like it, because it's an array, it starts from 0 0 1 2 3 and 4 and so on. So 0 1 and 2, so value should be 29 in this particular case. So as soon as you run this particular program, you will find that you get the element at this particular place, right? So this is how your particular set pair of functions are going to work around for the element access, for modifiers, right? If you want to insert a particular element, right? So if you're not aware that what is the code, what is the exact working for this particular function that you should be using, so you can actually go to that particular function definition and you can check that what is the basic functionality for that. So here, you can clearly see that this particular my vector has been defined over here. My vector is basically nothing. It's basically a particular vector object, and then an iterator has been created corresponding to that particular vector class, and that iterator is also going to be fast for that particular pet, right? So the iterator is being used to check on that, okay, which particular at which particular place do the element is required to be added, right? So if I use this particular piece of code, you can actually see the utilization of the iterator as well as the insert function, right? So here, let me go back, and here what we can do is we can have a particular cout situation. So here, not cout, the insertion situation. So list vector dot insert, right? So as soon as I have this particular parenthesis over here, you can see there are different kind of definitions we can have. The basic definition is that where you wanted to, the very first argument, you can see the where you want to insert and what is the element in each, you wanted to have into this particular part, right? So here, the list vector, I'm just going to just wanted to have a vector beginning, right? So list vector dot begin, right? So this is what I wanted to have. So this begin is going to get me the pointer to the very first index, right? And then if I want to have the value added, 200 added to that particular location, right? So in that particular case, we can see what change this particular list is going to have. So I'm going to use this particular for function into this, and let me just run this. So here, as soon as we get the beginning of that particular iterator, you can see the element has been added to the beginning of that particular part, right? So we got that particular beginning of the list, right? And list, or you can say the beginning of the first pointer we got in that particular list, and the element has been added into this particular part. Whereas if I take the another one, if I take the iterator at the end, right? So if I go and take the end, and if I put up the end value as 201, right? So here, this is for the insert at the beginning and insert at the end of the list, right? So this is a predefined function which has been provided. So you can see the element has been added to the beginning and element has been added to the end of this particular list, right? Now there's one more thing that you can do. So here, the third part I want to talk about here again itself, that is the algo. So if we want to utilize some kind of algo, right? So algorithm is the header file that I should include, and or the header preprocessor header I should include. And here, what I can do is I can just simply go and work on having the sort function, right? And this sort function should contain the beginning and the end of the particular vector that should be provided, right? So just to give you an idea that how should I how I know that what are the parameters which it should take, right? So let me take you back to the reference again. This is what you should always go and look into. Go to the others. Click on the algorithm, right? Click on the algorithm, and as soon as you click on the algorithm, you will find that there are functions which are being provided into this particular header file, right? So there are many functions which are there. There are non-modifying function, non-mutating functions, mutating function that modifies the particular sequence, right? There are partitioning function, there are sorting function, there are searching function, there are merging functions, there are heap related function, max min functions, and so on, right? So when you talk about the sort, right? So here is a sort function, right? So sort function is basically going to sort the elements in the provided range, right? So once you click on this particular sort function, you will get to see an example where you can see a vector is going to be provided. So my vector is going to be there, where the int is going to be given as the corresponding range, right? And the sort function is taking the first parameter as beginning iterator of that particular my vector and the ending iterator of that particular my vector, right? So if I take you back to the code, right, and if I try to do the sorting corresponding to that particular part, right? So here you can see the sorting is done directly onto that particular vector, right? So here, if a sorting is supposed to be done, so list vector dot beginning, right? So this is basically a pointer to the first location, list vector dot end, right? As soon as we have this particular list provided, and then if you try to check on that, what is the list, what is the condition of that particular list right now? Let me just execute this particular program for you guys. So here you can see, let me just do a segregation between them. Cout sorting of the list is done. So let me just do a new line over here, and let me just have endl so that we can have two lines added. So here you can see the list before sorting was only containing the elements. Let me just pull it up. Yeah. So here it is. So you can see before sorting the list, it was 209 and so on, and the last elements were 201, and here it has been done, right? So this is basically nothing more than the combination of functions that you are going to use. These are predefined functions. So we took an example of vectors over here. That vector is basically a container, one of the class from that particular piece of code. And just allow me to have my power attached to the system. So sorry. Just give me 1 second. I need to just set up my time it happens when you're doing live. Yeah, so we got our power back from the power source. Okay, so here, yeah, so here you can actually conclude that how a particular vector, which is basically a container, can be utilized for having a dynamic array based list, where we can have the corresponding functions worked out on them for different kind of use cases, right? And then we may have some additional iterators defined on them, not defined on them. Some iterators can be used, which is begin, end, or current. There are some iterators which are being predefined on that particular list. So let me take you back to the container vector, and let me just bring that vector over here. And you can see the container that it contains is basically begin, end, r begin, that means reverse, r end, that means reverse, c begin, c end, cr begin, and cr reverse, right? Depending on if we are using the constant iterators and so on, right? So we may use the pointers to access the elements, and we may use certain functions to insert the elements, to remove the elements, right? And then we can use the additional algorithms that are being predefined, where the iterators, or you can say the pointers, are being provided to give you the range to these particular piece of algorithms, so that they can work on them, and then we can utilize them directly, right? So this is what is all about in STL, right? So you need to find out, just concluding my session, you need to find out that which particular vector do you want to work around as corresponding to your present use case, right? And what sort of functionality do you want? Do you want to have some kind of randomized access, bi-directional access, and so on? So based on that, you will actually choose. Do you want to have a unique data? Then you are going to use go for set. Do you want to have a redundant data? That means you can use map or something like that, right? So this is nothing more than this piece of at these extended data structures, right? That can be used. So they come under the container part. Every container will have their iterator available for the access. The iterator is no more than a pointer, so you can do the pointer arithmetic on that as well. So once you have the container and pointer available with you, there is piece of algorithms that you can utilize, and those algorithms are basically going to be non-mutating or mutating algorithms. So and apart from that, you can have some additional functionality of partitioning the particular data elements through from your containers, sorting your containers, doing the search on the containers, doing merge on containers, and the relevant dynamic memory allocation on the container, and so on, right? So this is what you get in terms of your overall process, right? So that is what is all about STL, and rest is all that. If more you do the practice on by going through this particular reference, right, more you are going to get to know about the behaviors of that particular STL correspondingly, right? So this is what you get in terms of your overall STL based thing, right? So that's where I believe I can conclude this particular session. So if you have any kind of queries, questions, I am open for them, right? And yeah, so this is what is there from my side, right? So you have any questions, you have any kind of queries, I'm happy to answer them. And great, so that is what is from my side, because this is a very brief session, right? And if you are looking for more set of uh, concepts from my side on STL, I'm very happy to answer. I'm very happy to take on those things. And that is what I have. So if you have any kind of questions, you can just type in the comment section. I'll look at that. Otherwise, if you have uh, any suggestions that you want to share with me, or you want to discuss some further things, this is my email address where you can actually go and uh, talk about the particular discussion point, right? So that's it from my side in terms of the overall concept. So let me just stop my screen share and let me just bring in the yeah, stop sharing my screen. Yes, let me just bring my face for you guys. Yeah, so here I am. So you have any queries, anything you want to talk about? I'm here for you for another 2 3 minutes. Otherwise, I look forward for your feedback that you can share on hello@superbits.com. Let me just bring my email address on the screen. This is what I have. And in case if you have any feedback to share, any review to share, this is the link where you can actually go and share the feedback on, right? So let me just pull, yeah. All right, guys, seems like there is no one here. So thank you very much for joining in this particular session and sustaining till the end. So I hope I was able to add some value to your basic knowledge of STL, and I hope you are going to do the practice by using the reference from c++.com. That's a beautiful resource that every programmer should have handy for them. And yeah, overall, practice is the only thing that you can do. So just to recite one last time, containers are the one which defines the kind of data structures for you, and that they are basically generic template classes which are being defined uh, along with the along with the member functions which can do some operations on that particular data that these containers can contain. And apart from that, there's a algorithm. There are a certain set of algorithms, predefined algorithms that have been added to the STL, and you can directly use those algorithms on your particular piece of container objects. And container objects exposes the iterators, basically, which are pointers, which are going to help you out in doing the iterations or doing the or accessing the memory locations of the container data, right? So that is what brings you the capability, and those iterators are being consumed by the algorithms for their further functionality, right? So this is where the STL is going to give you an additional edge on writing a better piece of code, a better software product for the use case that you have at hand, right? So that is what is the crux of the overall 1 hour session. So thank you very much for all the patience. Thank you very much for all the support that you have given me during this particular live session. Hope to have your review on the link which has been provided on the screen. And in case if there is any specific queries you have, you can actually push it on to the hello@superwits.com, right? So that's it for today's session. Thank you very much. Bye bye. See you soon in the next webinar.